AWS Table Schema Design Description. Designing database schemas for AWS services involves planning the structure and organization of your data within AWS databases like DynamoDB, RDS, and Redshift. It ensures efficient storage, retrieval, and management of information for your applications and workflows. Prerequisites: understand relational database concepts. Familiarity with database terminology, including tables, columns, relationships, keys, and data types, is essential for designing effective schemas. Familiarity with AWS services like DynamoDB, RDS, Redshift. Knowledge of the features, capabilities, and limitations of these AWS database services is crucial for selecting the right service and optimizing schema design for performance and scalability. Use cases: storing user data for applications, storing user profiles, preferences, activities, and other relevant information for various applications like e-commerce platforms, social media sites, or cloud-based software. Analyzing large datasets. Designing schemas for storing and analyzing large datasets from diverse sources, such as log files, sensor readings, or social media interactions, using services like Redshift or EMR. Managing inventory and orders. Implementing schemas to track inventory levels, manage orders, process payments, and maintain a comprehensive record of transactions in e-commerce or supply chain management systems. Steps: define entities and their attributes. Identify the key entities or objects within your data model and determine the essential attributes or properties associated with each entity. For example, in a customer database, entities might include customers, orders, products, and addresses, with attributes like name, email, order date, product name, and shipping address. Establish relationships between entities. Define how entities relate to each other. This can involve one-to-one, one-to-many, or many-to-many relationships. For instance, a customer can place multiple orders, representing a one-to-many relationship between customers and orders. Choose appropriate data types. Select the appropriate data types for each attribute based on the nature and format of the data. Common data types include strings, text, integers, numbers, decimals, floating point numbers, dates, timestamps, and booleans, true, false. Optimize for performance and scalability. Consider factors like query patterns, data volume, and access frequency to optimize schema design for efficient performance and scalability. This might involve using indexes, choosing suitable storage options, and implementing proper normalization techniques. Challenges and fixes: data consistency issues. Ensuring that data remains consistent across multiple instances or replicas of a database is crucial for maintaining data integrity. Implement strong consistency mechanisms. Employ mechanisms like transaction isolation levels or distributed consensus protocols to guarantee data consistency, even in distributed environments. Consider using database services like DynamoDB with strong consistency options or implementing your own consistency logic. Schema evolution and migration. As applications evolve, schemas may need to be modified to accommodate new data requirements or changes in data structure. Use versioning and data migration tools. Implement schema versioning to track changes and facilitate smooth migration processes. Utilize tools like AWS Database Migration Service (DMS) for transferring data between different database instances or versions. Performance bottlenecks. Poorly designed schemas or inefficient query patterns can lead to performance bottlenecks and slow response times, especially when dealing with large datasets. Optimize query patterns and indexes. Analyze query patterns and design appropriate indexes to speed up data retrieval. Optimize data access and reduce unnecessary data scans. Consider using database features like query optimization hints or stored procedures. Security vulnerabilities. Databases can be vulnerable to security threats, such as unauthorized access, data breaches, or injection attacks. Implement access control and encryption. Enforce strict access control policies to restrict access to sensitive data based on user roles and permissions. Implement data encryption at rest and in transit to protect data from unauthorized access. Utilize security features offered by AWS database services like ing roles and encryption options. Data storage costs. Storing and managing large amounts of data can result in significant storage costs, especially for long-term data retention or archival purposes. Choose cost-effective storage options. Consider using various storage tiers offered by AWS services like S3 or Glacier for archiving infrequently accessed data. Leverage cost-optimized database instances or storage classes within services like DynamoDB or Redshift. Scalability limitations. Databases might encounter scalability limitations when dealing with rapidly growing data volumes or high concurrency demands. Use sharding and distributed databases. Implement sharding techniques to partition data across multiple database nodes for horizontal scaling. Consider using distributed database solutions like Amazon Aurora or DynamoDB to handle large datasets and high throughput.